So now we're going to learn how to graph logarithmic functions, so graph logs. And the problem is we can't really, without a calculator, plug a number into x and think that we can, without a calculator, know what y is. So what we have to do is we have to actually find the inverse of a log. And I think through everything we did the past 2 days, I think you have learned that logs and exponents are inverses of each other. So the first thing we need to do is we need to change this equation into an exponential equation. Remember, the first step in finding the inverse is switching the x and the y. So I'm going to, up here, switch the x and the y. And I'm now going to continue finding that inverse down here. So the first thing I need you to do is I need you to find space on the left side of your paper to change from the logarithmic equation to an exponential equation. So when I rewrite this down here, I'm going to write the log on the left. And remember, the base of the log becomes the base of my exponent. So that 2 becomes the base of my exponent. And then I cross the equal sign, 2 to the x equals y. And I have now found the inverse, and don't forget I need to put to the -1 because that indicates inverse. So I now know that the inverse is 2 to the x. I'm going to make a table for this inverse. So this is going to be the table for the inverse, and let's just make sure we know that. And remember, when we do inverses, we plot 0, A, and A in this case is 1, and 1, B. And then do any transformations that I need. But I don't have an A, it's 1, I don't have an H, and I don't have a K. So this is going to be my exponential function. And I'm going to plot that in white, 0, 1, and 1, 2. I know I have a horizontal asymptote of y equals 0, and my graph is going to look like this. Now remember, all I need to do now is I need to just switch my x and my y to make the inverse. So I'm going to switch this 0, 1 to 1, 0. And I'm going to switch the 1, 2 to 2, 1. And I'm now going to plot them. 1, 0, and 2, 1. And if you remember back to inverses, everything inverses. The x and the y switch places. The domain and range switch places. The table, x and y switch places. So the other thing you need to know is the asymptote completely changes. So instead of having a y equals 0 asymptote, I'm going to have an x equals 0 asymptote. So I'm now going to have an asymptote here. And I now am going to scooch right up along this asymptote this way, and this is going to be here. And if you remember what an inverse is supposed to do, it's supposed to look like it is reflected over the line y equals x, which I'm roughly putting in here. And it needs to look like, if I were going to do origami and I was going to fold along this line right here, that this graph would fold over and meet this graph, which it does. So this particular function right here, the green one, is the graph of y equals log base 2 of x. So again, in order to graph this function, which is a logarithmic function, I need to find the inverse of the logarithmic function in exponents. So I need to find the inverse first. So I'm going to come down here and change the f of x to a log base 3 of x plus 2. I'm just going to switch this side to this side. So I'm going to write log base 3 of x plus 2 equals y. I'm now going to switch my x and my y. I know the base of my exponent is going to be the base of my log, so that 3 becomes the base of my exponent. Remember, if I'm in logarithmic function, I'm going to exponential function, so I need an exponent here. So I'm just going to follow this across the equal sign. So my exponent's going to be that x, and I'm going to come back right in front of the equal sign to equal whatever's in that parentheses. I need to solve for y, so I'm going to subtract this 2 to the other side, and I'm going to get 3 to the x minus 2 equals y, and again, it's the inverse. So this function right here is the inverse of my original log function. I'm now going to graph this inverse. So the first thing I'm going to do is I'm going to look at this and realize that I have a 1 as an a, I have a 1 as an r, I have 0 as my h right here, and I have a negative 2. So I'm going to graph 0, 1, 0a, and 1b, which is 3. I'm going to multiply the y by any a, but it's 1. I'm going to add or subtract the h, which there isn't. I'm going to subtract 2 off the y's. So I'm going to subtract 2 off these. And I now have the table of this exponential function. I'm going to graph that exponential function so we can make sure it looks like what we've been graphing. I have a horizontal asymptote at negative 2, so I'm going to put that in there. And the equation of this horizontal asymptote is y equals negative 2. I'm going to put 0, negative 1 on there. It's hard to find that point with a mouse. And 1, 1. And here is the graph of my exponential function. Now I'm going to switch these points, and I'm going to write negative 1, 0, and 1, 1. And I'm going to plot those. Negative 1, 0, and 1, 1. But don't forget, if I have a horizontal asymptote at y equals negative 2, I have a vertical asymptote at x equals negative 2. So for my logarithm, I actually have a vertical asymptote at x equals negative 2. Everything switches. So this pink thing would be the graph of my log function. So this function is this pink graph right here. To go here, to graph this, I have to get the inverse, which is an exponential, by switching my x and my y. I make the table for this, which is right here, switch these x and y's. Now I want to look at domain and range, and the first thing I want to look at is I want to look at domain and range of the exponential function, the inverse function. So that's going to be this white graph right here. Remember, this is the exponential function. So the domain of this function is what we've always been saying, negative infinity to positive infinity. The range of that function, the white function, is bottom, which is 0. No, it's not. The bottom of that function is the asymptote, which is negative 2, to positive infinity. Now I want to look at domain and range of the pink guy. Notice domain is left to right. Well, this pink graph doesn't go past negative 2, so it's going to be negative 2 to infinity. Range is bottom to top. Well, the pink goes bottom to top, so it's going to be negative infinity to positive infinity. And notice these also switched. So not only did I switch my x and my y to find the inverse, after I made a table, I switched my x and my y to make the table of the inverse, and then my domain and range switch for the inverse. Okay, we're going to do one more. So again, let's just remind everyone what this ln thing stands for. This ln thing is called the natural log, and it really is log base e, and we'll actually use that when we find the inverse. So let's start finding the inverse. The first thing I'm going to do is I'm going to write it with the ln on the left. I'm going to change ln to log base e. I'm now going to switch the x and the y. I'm now going to change from a logarithmic function to the inverse. The base of my log is going to be the base of my exponent. I'm going to cross across the equal sign. That's my exponent. Now I'm going to come back right in front of the equal sign. I'm now going to take that -1, I'm solving for y, and I'm going to add it to this side. So I get e to the x plus 1 equals y, and this is the inverse. I'm going to plot 0a and 1b, which is e. We know e is approximately 2.72. I also know that I have this, I don't have an A, I don't have an H, I have a K. This shifts my whole thing up 1, which means I have a horizontal asymptote at +1. So I have a horizontal asymptote at y equals 1, which means my inverse is going to have an asymptote of x equals 1. So let's remember that. And I also need to add 1 to my y's. So this is going to change to 2. And this is going to change to 2.72 plus 1, so 3.72. I'm now going to plot those points, 0, 2, and 1, 3.72, which is about 4, so I'm going to try my best. I think the graphs on your worksheet are a little better. I also think you've noticed that the graphs of e's really don't look any different than the graphs of an exponential growth or decay function. They look the same because e is typically used for exponential growth and decay. So there is the graph of my inverse function. Remember, the white, this guy, is the graph of the inverse function. What I'm going to do now is I'm going to switch my x and my y in the table. So I now will get 2, 1 and 3.72, 1. And that really should be 2, 0, shouldn't it? Okay, I'm going to plot 2, 0, and I'm going to plot 1, 3.72, which is a little more than 3, 1. I also know I have a vertical asymptote. Instead of a horizontal at y equals 1, I have a vertical at x equals 1. And I'm going to connect these ordered pairs, and I have created my log. I want you to notice again that if I have graphed this correctly, it should look like it is reflected over this line, y equals x. And if I fold on that blue line, it does look like the white line will reflect over to the green line. Okay, so now let's look at domain and range of the inverse function. So the domain and range of the inverse function, domain of the white graph is -infinity to +infinity. The range of the white graph is bottom to top, which would be +1 to +infinity. Now let's look at domain and range of the green graph. So the domain is left to right. The asymptote is 1 to +infinity. I go left to right. Well, this green graph does not pass this vertical asymptote to +infinity. Now, range, this is going to keep going down to -infinity. This guy is going to keep going up to +infinity. So my range will be -infinity to +infinity. So again, I want you to notice the switches real quick. I switch the x and the y to find my inverse function. I create a table of my inverse function, and I again switch the x and the y to find the table of the function. I graph them. The asymptote switches from y equals 1 to x equals 1. They do look like they're reflected over the line y equals x, and my domain and my range reflect. This is the end of this one. I would like you to do number 4 for your entrance ticket.